maintain the limb's shape. A couple of hours later, it's stiff enough to be used as a negative mold. They pour in plaster of Paris, then insert a metal rod. The rod is what will later allow them to mount the dried plaster to work on it further. The plaster takes about an hour and a half to harden. They cut off the algin. Then, using sandpaper and files, they refine and smooth the surface. This plaster copy of the residual limb will now be used as a positive mold to cast the artificial limb. Often, they use a different technique to make the positive mold. They build a negative mold first using strips of plasterized cloth, much the same way they make a plaster cast when you break your leg. Then a scanner takes a detailed three-dimensional reading and programs it into a computer. A technician then makes any necessary modifications. They put a plaster block on a cutting machine. The computer guides the blade to carve out the positive mold. With either technique, once the positive mold is ready, they can make the artificial limb. The process they use is called lamination. First, they cover the mold in fabric socks. Some made of nylon, others of a material that contains fiberglass. They layer 6 to 10 socks in all, depending on how rigid they want the artificial limb to be. Then they coat the socks with a liquid resin made of either polyester or acrylic. Here they're using acrylic tinted to look like Caucasian skin. It's important to ensure the surface is evenly soaked. It's a meticulous process that takes about an hour. The acrylic solidifies in about an hour. Polyester takes about 12 hours. They then break the plaster mold inside, leaving a durable plastic shell called a socket. That will be the basis of the artificial limb. The socket connects to another plastic shell containing the mechanics. Or, like this artificial leg, the mechanism can be modular and covered in just a skin-colored foam. If the muscle at the site of the amputation still emits a good electrical signal when contracted, the patient can get a myoelectric prosthesis. It has an electrode that captures and amplifies the signal, triggering the artificial hand to open and close. As early as the 1400s, Africans made peanut stews. Peanut butter, as we know it today, was invented in 1890 by an American doctor. He used it as a protein substitute for people whose teeth were so bad they couldn't chew meat. The best peanuts for making peanut butter are runner peanuts because they're uniform in size. They roast more evenly than peanuts that vary in size. They arrive at the peanut butter factory already shelled. To make a 500-gram jar of peanut butter, it takes 565 grams of peanuts. That's about 1,100 peanuts. The first step is to roast them. The nuts travel through a hot air roaster heated to 204 degrees Celsius. The shaking motion moves them around so they roast evenly. More than 3,600 kilograms of peanuts go through this roaster per hour. When they come out, they've turned from white to light brown. Next, they go into another machine, which fast cools them at room temperature using suction fans that circulate air quickly. This rapid cooling process is critical. It halts the cooking and prevents the peanuts from losing too much oil. Next, the peanuts go through a machine called the blancher. It removes the outer skins by rubbing them between rubber belts. Then it splits the kernels and removes the heart of the peanut, which has a slightly bitter taste. But what's discarded doesn't go to waste. The skins go to farmers for pig feed, and the hearts go into bird feed. The peanuts land in a big stainless steel hopper. From there, they drop down into the grinder to be ground into a paste.